How far away is a satellite?
Hello everyone, welcome to the channel. In today's video, we'll learn more about calculating the distance between spacecraft and Earth stations. To perform this calculation sample, we need to consider that the Earth model is also simpler. We'll leave aside the geoid model and use the spherical Earth model on the right. Another consideration arises when analyzing the existing orbital types. For example, we can have a geostationary orbit with a 0-degree inclination, or we can have a medium orbit with a 125-degree inclinations. However, in this exercise, the use of low orbits up to 2,000 kilometers or approximately 6 million feet with a 90-degree inclinations is recommended. Supposing we want to design or study a link between satellites in space and antennas on Earth. First, find the latitude, longitude, altitude of the satellite and ground stations. For example, latitudes different or longitude different. This is a geographic coordinate, very utility for localizations, vehicles in the surface Earth. This input data can be created by STK and MATLAB softwares, for example. Second, calculation altitude. We used this Brazilian book indicated on the screen to extract Newton's equations and centripetal force in order to find a way to calculate the vehicle's altitude in space. Below, we have descriptions for these elements, the equations. Law of cosine for sides. In this case, the bibliography used is from North American. Instead of using traditional planar trigonometry, we need to apply the concepts of spherical trigonometry. So imagine a watermelon and we cut a piece with the 3 sides. These sides are angles, which can be found by this equation to cosine A. By solving these calculations using null values, we find the much anticipated distance between these 2 points. But why real importance for calculating the distance between satellite and ground stations or control-wise? The Friis equations for data transmissions can answer this. Whenever it's necessary to analyze, calculate, or design a communications project with at least 2 elements, one sending and the other receiving electromagnetic signals, it's necessary to have some basic information such as power transmitted or received and gain transmitted or received, or wavelength and distance between transmitter and receiver. And naturally, in projects or exercises like this, one of the most important functions to solving the distance between these antennas. Yes, there are antennas on the satellite too, and as we saw previous, this is an exercise in trigonometry that is in the positions of points in space. So, to recap, one way to find this distance is by applying the equations we discussed throughout this video. Obviously, there are other ways to do these calculations, so if you are interested in exploring these different approaches, please comment below this video so I can understand your needs. This way you support all our work. Finally, we have two distances. The first, Earth stations and satellite, is an uplink, and satellite second Earth stations is a downlink. And this is how the famous satellite communications occur. Of course, this is just a simplification of all types of the satellite applications in the Earth, enabling our daily calls as well as video conference and the like. Since we are talking about space missions, did you know that in addition to the telecommunication subsystems, a satellite requires at least 6 other subsystems to stay in orbit? If you are curious, comment below, and thank you for your attention.